6.1 Trigonometric ratios for any standard position angle, part 1. So when we are talking about an angle in standard position, we're going to think about the quadrants. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Angles always go in a counterclockwise way. That's how we measure our angles. And wherever the angle lies, we call it that terminal arm. So it could lie here, it could lie here, it could lie here, it could lie literally all sorts of places. So that's called the terminal arm. So we're going to find all angles that are coterminal to 50 degrees. So first of all, if I draw 50 degrees, that's going to be here in quadrant 1. And we show the measurement like this, from 0 to 50 degrees. A coterminal angle to this means that it lies in the exact same position, so it's still there, but it's no longer 50 degrees. So a coterminal angle, for instance, could go one full circle plus another 50 degrees, so it could be 410. Another example of this could be two full circles and then another 50 degrees, and that would be 770 degrees. We also can count negative angles, so it could still be in this position, but instead of counting this way, which is the positive, we would count this way, which is the negative. So what that would mean is this is 50 degrees. We have negative 360 minus that remaining 50 degrees. So it's kind of like saying plus 50 degrees. So it's the same as negative 310 degrees. So those are all things that are coterminal. They lie on the exact same arm. And we can make a general statement of that. So the way that we would say a general statement is that our angle could be equal to 50 degrees plus we add 360 degrees times some value of k. So for this one, k would be 1. It adds one circle. This one is 2. This one is negative 1. So it's k, and then we say for k is an element of the integers. So the symbol z is integers, and that means plus and minus whole numbers. Okay, determine all the measures in standard position between negative 800 and 800 that are coterminal with 85 degrees in standard position. Sketch those angles. So first we got 85 degrees. That would be like this. Now we're going to do all our positives. So we could go 360 plus 85. So we're going to use this logic here. So we're going to go 50 plus 360 times k, where k is an element of z. So we're going to go 50 plus 360 times 1, which is plus one circle. And I would get 445. Let's try another one. 50 plus 360 times 2. And I would get 805. So that's too big. That's not within our domain anymore, so that is out. So we're done with positives. Let's do 50 plus 360 times negative 1. And I would get negative 275. So that one's good. 50 plus 360 times negative 2. And I would get negative 635. So that one's good. 50 plus 360 times negative 3, and I get negative 995. So that's too far. It's outside of our domain. So all of the answers will be negative 275, negative 635, 445, and the original 85. And if we were to sketch those, this one would be one circle plus a bit more. This one would be like that. This one would be a full circle plus 85, and then we're done. So that is what coterminal means. Okay, so we're pretty familiar with the trig ratios of sine, cos, and tangent. So know that sine is our x value over our r value. So the reason why this works is if I have a point and it's coterminal, this is my angle, and it's every point on the terminal arm will make a point of x and y. So if I was to label this, my r value is my hypotenuse, my y value is my opposite, and my x value is our adjacent. So when I say y is equal to opposite over hypotenuse, for so, it's going to be our y over our r. So that's why we get sine is equal to y over r. And cos is equal to x over r, and tangent is equal to y over x. So we also now have these reciprocal identities. So we have secant ratio, and the secant ratio is r over x, which looks a lot like cos. So if I say 1 over cos, that is the same as our secant theta. Our cosecant is very similar to sine, so it's 1 over sine theta, and that makes my cosecant theta. And our cotangent theta is x over y, and it's 1 over tangent theta. So those are our new trig ratios. So let's fill out some of this info over here. So we have the points quadrant 1, x and y are both positive. In quadrant 2, our x becomes negative and our y is positive. In quadrant 3, our x value is negative and our y value is negative. And in quadrant 4, our x value is positive and our y value is negative. So what that means is that in our sine ratio for quadrant 1 is going to be y over r. Just so you know, r is a length, so it's always positive. Our cos is x over r. Our tangent is y over x. Our cosecant is r over y. Our secant is r over x. And our cotangent is x over y. They are all positive. In quadrant 2, the ratios all stay the same, except we can see that some of them turn negative because we have x values that are negative. So they all stay the same. And the things that you should notice that stay positive for red are sine and cosecant. So in quadrant 1, they are all positive. In quadrant 2, only sine is positive. Oops, I wrote that backwards. In quadrant 3, they're both negative. So we have negative y over r, so sine is negative. We have negative x over r, which is negative. And now we have y over x. And if I put negative y over negative x, that would make it a positive. So tangent's going to be positive in this quadrant. This should be an x. And that means that my cotangent is also going to be, so it'd be positive x over y. And these will both be negative. Not because the r is negative, but because the y is negative. I'll rewrite that. Okay, so only tangents are positive there. In the last quadrant, we have negative y, so negative y over r. X stays positive, so my cosine remains positive, which means that my secant is also going to be positive. So we have y over negative r over negative y. This one remains positive, and we have x over negative y. So you can remember this by the acronym CAST, C-A-S-T. You can also remember that all strippers take cash. I don't know how appropriate that is. I probably shouldn't say that joke. but you probably won't forget it, right? Or all students take cash. I don't know. All students take class. That's a good one. All students take class. Nice. I'm so smart. Okay, so that's kind of an important deal. Cast is important. I learned it as cast. And I'll always remember it like that. Okay, determine the length of the length of r using the point P of x and y. So this is a right triangle, so if I wanted to find the length of r, I would use the Pythagorean theorem. So I would use r squared equals x squared plus y squared. So r is equal to the square root of x squared plus y squared. I also can find the point x and y. So if I wanted to find the point x and y using r, if I look at this, I can use cosine. So I can say cosine of theta is equal to x over r. And if I wanted to find x by itself, I'd times both sides by r. So I have r cos theta. If I wanted to find y, I would use sine. So sine theta equals y over r, and I'd multiply both sides by r. So r sine theta equals y. So we often use this as to figure out the point. So it's r cos theta, r sine theta. So you're probably going to want to remember this formula as well as this formula for later. Okay, the example at the top says to find all angles with a reference angle of 30 degrees. So what a reference angle is it's the smallest angle that is made with the terminal arm and the 180 degree line. So this is a reference angle of 30 degrees. I also have it in quadrant 2. In quadrant 2, this would be 30, which means my standard angle would be 180 minus 30, so it would be 150. So that's how you can do it in quadrant 2. In quadrant 3, it'd be down here. So that's my 30. So to get my standard angle, I would have to add another 180 to it. So 180 plus 30 is 210. So that would be my angle in quadrant 3. And in quadrant 4, it'd be right here. So I would want to do 360 minus 30 to get my reference angle of 330 degrees in quadrant 4. So lots of that's just logic. You can memorize formulas for it, but I mean, I feel like you should probably be able to use logic for this. So this is important for us because it's going to help us determine some primary trig ratios. So our special trig ratios are 0, 90, 45, 30, and 60. So 0 is easy and 90 is easy because this point would be 1 to the right and 0 to the left. And when we're dealing with a unit circle, we're always going to deal with our smallest values. So let's do sine of 90 degrees. Or 0 degrees. Let's do sine of 0 degrees. So sine of 0 degrees has a rise of 0 and a run of 1. So it'd be 0 over 1, which is 0. Our cosine of 0 degrees has a run of 1 and a length of 1, so it's 1. Our tangent of 0 degrees has a 0 rise over a run of 1, so it's 0. Now we're going to go cosecant. So cosecant is the flip of our sine function, so it'd be 1 over 0, which is undefined. I don't want to write the whole word. Secant theta, or secant of 0 degrees, is equal to 1, because the reciprocal of 1 over 1 is just 1. And cotangent of 0 degrees is also going to be undefined. So there are all of our ratios for 0 degrees. Now we're going to do 90, so that's this point right here. Sine of 90. So we have, this time we have a rise. Our y is equal to 1. Our x is equal to 0. And our r is equal to 1. So this one will have 1 for our sine. Our cos of 90 degrees, our x value is 0, so it's 0 over 1. And our tangent of 90 degrees is going to be undefined because it's going to be y over x, which is 1 over 0, so undefined. Now we will do cosecant. So cosecant of 90 degrees is going to be 1, because it's 1 over 1. Secant of 90 degrees is going to be 1 over 0, so undefined. And cotangent of 90 degrees will be 0 over 1, so it will be 0. So there's all of our primary trig ratios for 0 and 90 degrees. Now we're going to do the 45 degree angle. So here's our 45 degree angle. It's 1, 1, root 2. And we just always use this triangle. It's called the 45 degree triangle. So for our sine function, our sine of 45 degrees is going to be 1 over root 2. Our cosine of 45 degrees is going to be 1 over root 2. And our tangent of 45 degrees is going to be 1 over 1, so 1. Now we'll do the reciprocal to figure out all of our others. So we have cosecant of 45 degrees is equal to root 2 over 1, so root 2. Secant of 45 degrees is also root 2. And cotangent of 45 degrees, the reciprocal of 1 over 1 is 1. Alright, now we have the 30, 60, 90 triangle. So it goes 1, 2, root 3. So let's do 60 degrees first. So from 60 degrees, my opposite side is root 3, and my hypotenuse is 2. So sine of 60 degrees is root 3 over 2. Cos of 60 degrees is going to be adjacent over hypotenuse, so 1 over root 2. Just a normal 2. There's no root there. Relax there, Miss Douglas. Tangent of 60 degrees is opposite, so root 3 over 1. Now we can go cosecant of 60 degrees, and we're just going to flip our sign, so 2 over root 3. Secant of 60 degrees is the flip of our cosine, so 2 over 1, so 2. I don't need to write over 1. And cotangent of 60 degrees is going to be the flip of tangent, so it's 1 over root 3. Looking at 30 degrees, we're going to look now from this side instead of from the 60. So my opposite side now becomes 1. So sine of 30 degrees is going to be 1 over 2. The hypotenuse always stays as 2. Cosine of 30 degrees is going to be adjacent over 2, which is root 3 over 2. And what you should notice is that the sine and the cosine flip. And when we do tangent of 30 degrees, it's the reciprocal of that 60 degree angle. It's 1 over root 3. So they are related in that way. To find our cosecant of 30 degrees, we're going to flip this, so it'd be 2 over 1, which is 2. Secant of 30 degrees is the flip of cosine, so it'd be 2 over root 3. And cotangent of 30 degrees is equal to root 3 over 1. So those are our primary trig ratios. We're going to use these a lot. We're also going to be using what we call the unit circle a lot. So the unit circle, it's its own video. I'd like you to watch it separately. But the unit circle is actually going to count, and it's going to show all of our degrees in a circle. It's also going to show all of our points. So this point of x and y. And our point's always going to be cos, then sine. And it's also going to show all of the radians. And we're not going to do radians until the third lesson. But if you want to watch that beforehand, you're more than welcome to. I will go through how to count out a unit circle. And it's something that you should be able to do from memory. but also when you write the test, not the quiz, but the test, you should have filled in one. And you're going to use it a lot. You're going to use it a lot in this unit, and you're going to use it a lot in the next unit. That's just the way she goes. That's the way she goes. Okay, let's utilize this. So determine the exact values of the 6 trig ratios for the following angles. Okay, so we have negative 420 degrees. So what we're going to do is we're going to find the reference angle. So if I take negative 420 and I'm going to subtract, we're dealing with negative angles, so I'm going to subtract negative 360. That's the same as adding 360. And what I get is negative 60 degrees. So my reference angle is 60 degrees. So if I was to sketch this angle, it'd be a 60-degree angle going one full circle and then another 60 degrees in that quadrant 4. So what I know about quadrant 4 is that only the cosine is positive in that quadrant. And I also know it has a reference angle of 60 degrees. So 1, 2, root 3. We can use this triangle to solve for all of our trig ratios. So if I wanted to do the sine of negative 420 degrees, it is, because it is has the same reference angle as 60, we can use the 60-degree angle to find our sides. So opposite of 60 is root 3, hypotenuse is 2, and because it's in quadrant 4, only cosine should be positive, so I'm going to make my answer negative. And that's your solution. If we go sine of, we already did sine, nice. If I do cosine of negative 420 degrees, I'm going to go adjacent, which is 1, over hypotenuse, which is 2, and cos is allowed to stay positive. And we're going to go tangent of negative 420 degrees is opposite, so root 3 over adjacent, which is 1, and it is negative because only cosine can be negative in that quadrant. We can also do our reciprocal functions, so we have cosecant of negative 420 is equal to negative 2 over root 3. We don't change the negative sign, we just flip it. Secant of negative 420 is equal to 2 over 1, which is 2. And cotangent of negative 420 is equal to negative 1 over root 3. So there are all of our trig ratios for negative 420 degrees. It's the exact answer. Yeah, so let's do 495 now. So 495, we're going to figure out our reference angle by subtracting 360. And what I'm left with is 135. So 135 is in quadrant 2, and it has a reference angle. If I go 180 minus 35, we get 45 degrees. So this angle goes one full circle plus another 135. So in this quadrant, the only thing that can be positive is sine, but it is the same as a 45-degree angle, so 1 root 2. So I'm going to say sine of 495 is equal to opposite over hypotenuse, so that's 1 over root 2. And sine stays positive. I'm going to do cos of 495 is equal to adjacent over hypotenuse, which is 1 over root 2, and because it is in quadrant 2, it has to be negative. And tangent of 495 is equal to 1 over 1, and it's a negative. We can do the reciprocals of these, so cosecant of 495 is equal to root 2. Secant of 495 is equal to negative root 2. And cotangent of 495 is equal to negative 1. So it doesn't change. Last one, determine the approximate values of 6 trigonometric ratios for 586. So because it says approximate, we do not need to use exact. We do not need to find a reference angle, so we're just going to type it in. So we're going to type sine 586, cos 586, tan 586. And then to get cosecant 586, we're going to type in 1 over sine 586. To get secant, we're going to type in 1 over cos 586. And to get cotangent, we're going to type in 1 over tan 586. So I want you to pause the video, and I want you to type this in and write down the decimals to 3 decimal places, not 5. So you should get negative 0.719. I can't tell if that's a 9 or a 4, what I've written down. Whatever, I'm sure you'll figure it out. We have negative 0.695. We have 1.036. Negative 1.390. Negative 1.440. And 0.966. If you didn't get these numbers, check to make sure your calculator is in DEG mode. You're going to have to be able to change your calculator between DEG and RAD a lot this unit and next unit. So make sure that when we're dealing with degrees, it says degrees. And that is the end of the first lesson. So make sure you subscribe below. Thank you for coming to my channel. Use my code, #Doug, for a discount on free loose sleeve. Okay, bye.